The mystery of a sudden shake of the earth that formed a large crack in Michigan has been solved. After 5 years of investigating, researchers believe the event, which was equivalent to a 1.0 earthquake, was actually a phenomenon known as a pop-up. By slamming a sledgehammer against a metal ball on the ground, researchers discovered a sharp buckle in the limestone that formed a bulge underneath the clay soil. Within a day, residents discovered what we now identify as a pop-up feature. Due to the extensional crack along its crest, it has become known as the Menominee Crack, according to the study from Michigan Technology University that is published in the journal Seismological Society of America. Within a few days, physical observations were made, and an additional geophysical survey was conducted in 2013 to further investigate the origin of the crack and associated ridge. Around 8:30 a.m. on October 4, 2010, the small town of Menominee heard a loud boom and felt the earth tremble. The following day a 360-foot-long, 5-foot-deep crack was discovered on ridge in the Menominee forest. Trees laid bent over the crack at about 14 degrees on each side and torn roots protruded throughout the inside of the curvy split. I was completely blown away by it, because it wasn't what I was expecting when I saw it, Wayne Pennington, Dean of the College of Engineering at Michigan Technology University said. It wasn't like anything I had seen before. Pop-ups are known to occur in areas with shallowly buried rock layers that spring upward because they were once weighed down by rock or ice. They may also happen in places where the earth rebounds upward after an overlaying glacier shrinks away or when rock overburden is removed in a quarry. But researchers learned the last glaciers disappeared from Menominee 11,000 years ago and the area isn't a quarry anymore. One of our reasons for publishing this was that in our search of the literature we could find no other mention of modern pop-ups that didn't occur at something like the base of a quarry, where people had removed massive amounts of rock earlier, Pennington explained. As far as we can tell, this is a one-of-a-kind event. Although researchers cannot identify the root of the pop-up, they do have a better understanding of what happened beneath the surface, reported Live Science. The team created sound waves with a hammer to investigate what was happening below them. By slamming a sledgehammer into a metal ball that sat on the ground, they were able to listen how the waves passed through the soil and rock layers below. And what they found was a sharp buckle in the limestone below the clay soil. The limestone was heaved upwards, forming a bulge when the pop-up appeared, and the crack is a result of the surface clay stretching as it was bent upwards and moved the overlying clay layer. The limestone in the area may have been stressed almost to the point of cracking when the last glaciers retreated, researchers explained. An auto-leveling and seismic refraction survey performed at the site revealed a bedrock layer approximately 2 m underneath the glacial till and also found a significant difference in bedrock velocities observed parallel and perpendicular to the crack, reads the study. Modeling of a fractured limestone, assuming the seismic ray paths cross fractures in one direction but not in the other, is consistent with these velocities. Another factor could have been the removal of a 2-ton white pine tree that was struck by lightning a few weeks prior to the crack. This event would have triggered the rock to bend upward when the weight of the tree was removed. There's a 60% chance that this explanation we provide is the right one, Pennington noted. But since we haven't seen this kind of thing elsewhere, and the tree is such a small effect, we wonder if there might be something else.